and welcome to our 5G networks video. In this video, we're going to be talking about 5G networks in relation to their application within natural disasters. This video will look into 5 major points, which are 5G introduction, why 5G is needed, the functional specifications of 5G, the technical specifications of 5G, and finally, how it can be applied to natural disasters. Now we're going to be talking about 5G and the telecommunication evolution, beginning from 1G. Now, everything needs to evolve to be better for the future. So, as is the case with telecommunication. The change in nature along the transmission of service is compatible to transmission technologies. Now, the first telecommunication network was 1G. It was developed in 1982 as a voice service based on the advanced mobile phone systems. Now we move into the evolution of 2G to 4G. With 2G, based on GSM, Global Systems in Mobile Communication, it uses digital signals for voice transmissions in kilobytes. Now, 2G had to jump to 2.5G, serving as a median for the next evolution of mobile networks. 2.5G, they introduced packet switching and circuit switching domains, arriving at rates as high as 144 kilobytes per second. Then we arrived at 3G, adding multimedia facilities and allowed division through CDMA. Then we arrived at 4G, which is the next step of telecommunication evolution, helping to add LTE, standing for long-term evolution, a multimedia-driven design. It can transfer and receive data up to 100 megabytes per second. Now, the upcoming standard of telecommunication networks is 5G. 5G is the latest development being done in the evolution of wireless networks. With 5G, it promises to do tasks such as improve broadband responsiveness and speeds up to 20 gigabytes per second, exceed wireline network speeds, and will offer minimal latency for real-time feedback. However, 5G will not be commercially available until the year 2020. Now we will get into why 5G is needed. In this section of the video, we will discuss how 5G works and why it should be used. We will look deeper into the explanation of 5G, connections to 5G, and have a look at LTE. 5G network is entirely IP-based for wireless mobile networks interoperability, meaning it can exchange and make use of information. It is a packet switch network, meaning that the data is transmitted independently from the access and transport networks, or layers. It operates with a user terminal and independent autonomous radio accesses, for RAT for short. It connects reconfigurable multi-technology cores, linking it to cloud computing resources, and it consists of a core of nanotechnology, cloud computing, and radio based all on IP platforms. Now, the core switches its connection features on the current situation of the network, as well as the user demands to ensure great connection to the network. The next thing we will look at is the components of radio in 5G. RAN, standing for Radio Access Networks, has various types of facilities and network connection methods to be able to connect to the main network. It involves setting up small cells being distributed into clusters leading to a particular MMM wave, which is a short-range connection complementing the micro network to provide extensive area coverage. Next, we will talk about the two components of radio core, MIMO, multiple input, multiple output, and OFDM, orthology frequency division multiplexing. For MIMO, it requires many antennas to be with multiple elements or connections in order to allow a complex digital signal processing. It is used to be able to send and receive more data simultaneously, allowing more people and individuals to simultaneously connect and maintain a high throughput. For OFDM, it is a transmission employing a greater number of proximity carriers at low rates. This means that the spectrum effective scheme that enables higher data rates to end users which are sharing a common network. LTE, or long-term evolution, employs both forms of duplex operations, first being FDD and TDD. LTE advances in evolution, or LTE operation, on 6 building blocks, which are 3-layer relays, no MIMO, low latency, COMP, heterogeneous network, and carrier aggregation. Now we will move on to the functional specifications of 5G. We have a timeline of 5G, investigating starting point with the functions, the challenges, the future developments, and the future uses of 5G networks. The primary advantage of 5G network over 4G is that the reduction in latency. The latency ranges between 1 to 10 microseconds and uses a frequency up to 30 to 300 gigahertz. 5G supports higher capabilities for data transmission and can support the increasing demand of bandwidth. Furthermore, it has a high multi-directional signal, which increases stability by using multiple wireless signals simultaneously without causing any interferences with one another. The challenges faced by 5G present themselves in the form of IoT and number of connections predicted, as is going to be a massive increase in the connections. This linear growth in data volumes averagely used by mobile devices is going to lead to higher data usage, and matching that data usage without increasing operational costs will be one of the major challenges faced by 5G. Also, consistency in latency and usage allows progression in the iteration of augmented reality. So a challenge of 5G would be in integrating and perfecting device-to-device communication, allowing for this to further expand. The future development of 5G looks bright because it is near completion. With 5G becoming a reality soon, it will help enhance mobile broadband. It will revolutionize mobile experience with supercharged wireless connections. Furthermore, with 5G, it can help in the entertainment and multimedia section. It is said to have to satisfy 120 frames per second, allowing for high resolution plus further implementation of audiovisual progression. There are many areas where 5G can be used in a feature. For example, AR and VR require high-D videos. With 5G, it enables future investments into these technological developments and progressions. It can also be used for smart homes and smart applications, and real-time home video camera access. Other than that, it can be helped in autonomous driving with cars, being able to communicate with one another, the road, and the traffic lights in its surroundings. Finally, it can be used for healthcare, as doctors will be able to do tasks like see a patient or conduct operations from a huge distance. Now we move on to the technical aspects. Proceeding to the networking aspects of 5G, we arrive at energy-efficient mechanisms and routing. Now, energy-efficient mechanisms, there are 5 main technologies employed by 5G to obtain high energy performance, including ultra-lean design, autonomous beam forwarding technologies, separation of user data and system control planes or radio interfaces, virtualized network functionality, along with additional functions. 5G energy efficiency would promise us small cells, allowing for heterogeneous networks and software-defined networks, controlling separate data and control panels across the network. It also allows for machine-to-machine communications, allowing for critical and massive deployments along networks, thus giving us the benefits of energy performance, which are, number 1, more time without transmission compared with existing cellular technologies, and number 2, more extensive or deeper sleep levels, allowing for a larger number of the devices to be turned on and saving electricity. The routing is also very important, as it allows for emergency services to communicate with one another. With 5G, it allows for prioritization and control over the network signals, meaning that you can prioritize emergency vehicles using intelligent transportation systems using network slicing. It guarantees that the network services used by medical or any other emergencies services are not interrupted or affected by any increase in usage nearby. For example, emergency services would be able to conduct traffic management, telling them their approach and enabling traffic management to modify the traffic for ease of route to emergency locations. With this implementation, 5G can significantly improve emergency services attending without affecting the lives of the users or the patients in danger. Now associating it to specific natural disasters. Natural disasters present an unpredictable and unavoidable threat. When they occur, natural disasters affect factors required for connections. For example, it leads to loss of electricity or stable access points, leading to loss of direct contact and strategic analysis. Now, network issues lead to search and rescue missions, interruption of which can result in very high damages. It also runs out connections from standalone communication systems, situational awareness and logics, disaster information fusion, and it prevents monitoring and forecasts and EWS. As was the case in Puerto Rico, suffering from seasonal hurricanes, Hurricane Maria toppled 95% of the data towers of Puerto Rico. Majority of the nation accessed their internet through mobile devices, and thus, when the towers fell, it led to loss of connection and access. The current solution is Google's Project Loon, which are air balloons inflated and sent around the network to be able to provide internet connection. If 5G was applied within this situation, it would have the advantages of number 1, independent autonomous power cells, allowing each signal or tower to be able to operate autonomously. It allows machine-to-machine communication for fully censored networks. Now, access to internet critical components with low latency, allowing for immediate and accurate warning signs. It also allows for communication paths along for warning, rescue, strategic, and decision making. As is the case in Puerto Rico, 5G networks would present a more reliable, accurate method to secure connections and a better way for lives during natural disasters. Thank you.